Hello, my name is Amit and today I am going to discuss few techniques of implementing switch security. First we will be discussing VLAN and Inter-Vlan. To begin learning about VLAN, first we need to know some few things about switch. Switches are used to manage a content addressable memory table. Layer 2 switches and bridges are faster than routers because they don't take up time looking at the network layer header information. Instead, they look at the frame's hardware addresses before deciding to either forward, flood, or drop the frames. Their primary functionality is to address learning. Layer 2 switches remember the source hardware address of each frame received on the interface and enter this information into the MAC database called a forwarder or filter table, or followed by forward filter decisions, loop avoidance, etc. So what is VLAN? VLAN network adds, moves and changes are achieved by ease by just configuring a port into an appropriate VLAN. A group of users that need an unusually high level of security can be put into its own VLAN so that the users outside of the VLAN can't communicate with it. As a logical grouping of users by function, VLANs can be considered independent from their physical or geographical locations. VLANs greatly enhance network security if implemented correctly. VLANs increase the number of broadcast domains while decreasing their size. Two types of ports are involved in VLAN configuration. First is access port. An access port belongs to and carries the traffic of only one VLAN, whereas trunk ports can similarly carry multiple VLANs at a time as well. Moving on to some additional information, there are few switch port modes that we need to discuss. First is switch port mode access. This puts the interface into permanent non-trunking mode and negotiates to convert the link into non-trunk link. The interface becomes a non-trunk interface regardless of whether the neighboring interface is a trunk interface. The port would be a dedicated layer to access port. The second one is switch port mode dynamic auto. This mode makes the interface able to convert the link into a trunk link. Third is switch port mode dynamic desirable. This one makes the interface actively attempt to convert the link into a trunk link. The fourth is switch port mode trunk. This puts the interface into permanent trunking mode and negotiates to convert the neighboring link into a trunk link. Then there is switch port no negotiate. This prevents the interface from generating DTP frames. You can use this command only when the interface switch port mode is access or trunk. You must manually configure the neighboring interface as a trunk interface to establish a trunk link. Then we will discuss few VLAN identification methods. So like how to identify VLAN. First is interswitch link, ISL. Interswitch link is a way of explicitly tagging VLAN information into an Ethernet frame. This tagging information allows VLAN to be multiplexed over a trunk link through an external encapsulation method. This allows the switch to identify the VLAN membership of a frame received over the trunk link. ISL is proprietary to Cisco switches and it's used for fast Ethernet and gigabit Ethernet links only. ISL routing is pretty versatile and can be used on a switch port, router interface and server interface cards to trunk a server. Although some Cisco switches still support ISL frame tracking, Cisco is moving toward using only 802.1q. Second is IEEE 802.1q. This is created by IEEE as a standard method of frame tagging. IEEE 802.1q actually inserts a field into the frame to identify the VLAN. If you are trunking between a Cisco switch link and different brand of switch, you got to use 802.1q for the trunk to work. Unlike ISL, which encapsulates the frame with control information, 802.1q inserts an 802.1q field along with the tag control information. Now let's quickly move on to VLAN and Inter-Vlan demonstration. Now to begin with VLAN security, I have already configured the initial setup to save some time. Let's go to switch 0, command line interface, type enable, type conf t, VLAN 10, we'll create VLAN, then name it as sales, then create VLAN 20, then name it as IT. Exit, enable, configure T, go to interface F0/1, the first interface, change the mode to access, then add it to VLAN 10, then go to interface 2, and also add this to VLAN 10, but similar way we have to change everything to access mode to configure the security as discussed in the presentation. Go to interface 3, change the mode to access, keep it as VLAN 20, interface 4, similarly add this to VLAN 20, go to interface 5, which is connected to the router, and change the switch port mode to trunk. We'll be using this for the inter-VLAN communication. Now if we try to ping PC2, then you will see that we are able to connect since it is in the same VLAN. But if we try to ping PC3, which is in VLAN 20, we won't be able to do so. This scenario that we are doing right now is called router on a stick. Go to enable, conf t, interface, no shed, so that we can activate it. Now use this syntax for encapsulation. So we have created a sub interface so that it will act as a default gateway for each of the VLANs, and we have already configured the gateways, as you can see. I'll give it as 1.1 because that's what we have configured for VLAN 10 PCs.
Then create another sub-interface of Vlan 20. Then use the encapsulation command. So I'm giving 2.1, which we have configured into PC3 and 4 of Vlan 20. One thing to notice, we can't assign an IP address to the router's physical interface that we have subdivided into logical sub-interfaces. We'll instead assign IP addresses to the sub-interfaces. Now if we try to ping, there it is. Now it is able to connect to the PC3. That's it with the VLAN demonstration.
Now we'll have a look at port security. Port security is to protect the switch port by anyone who just plug into and play with your network. By port security on a switch, port restricts port access by MAC addresses. We need to change the port out from desirable mode and make it into access port instead. If we don't do that, we won't be able to configure the port security on it at all. Sticky command can provide static MAC address security without having to type in the absolute everyone's MAC address on the network. VLAN also can control the broadcast. There's not much to talk about port security, and we can directly move on to the demonstration.
So let's quickly go to switch, command line interface, enable, configure terminal, switch port, first we have to go to interface, then type in switch port mode access, switch port mode port security, switch port security maximum 1, so that we allow 1, then violation shutdown, then switch port security MAC address, then give MAC address of PC0, we'll check the port security on the interface level. So it's enabled and violation mode is shut down, so everything looks good over here. We will check the running configuration. So the entry has been made. Let's connect PC0 and check whether it shuts down on connecting the actual configured one. Let's wait for a while. Okay, so the symbols have turned green, so the interface is up. Now let's delete and try to connect any other PC1. Okay, it's still green, so we'll go to command prompt, try to ping once again. Okay, so now it was able to recognize the connection and shut it down. Now let's delete this. Now we'll try for the sticky command. Similar way, go to conft go to the interface, similar commands, switch port mode access, then switch port security, maximum 1, violation shutdown. And now instead of giving MAC address, we will type in sticky. See, both options are available. Check the running configuration whether the commands have been updated. So as you see, we have just updated up to sticky. Now show port security. It's important to check the port security at the interface level so that we know that our configuration is correct. So yes, it's enabled and violation mode is shut down. So we connect the PC to interface 2. So what we are trying to do is, for the sticky interface, we want PC1 to be configured. So the MAC address is not updated yet. So what we will do is, we'll again try to ping and give a notification or inform your presence to the switch. So now if you check the running config, the MAC address will be present. Let's disconnect this link. Connect another PC to the interface 2. So we, like I said, for in packet tracer we have to ping once to tell our presence to the switch. So let's ping. Definitely you will get request timeout because there is no one on the other side, but the switch will get informed. So once we ping, see the symbols have turned red. It means the interface is down. Now go to command line interface. Go to port security, maximum 2. What we are trying to do here is, we want the second PC to be accepted on the interface. So we delete the link, connect it once again. Okay, switch
interface was shut down, so I did a no shut to enable it again. Now we try to ping and tell our presence once again and see whether it shuts down. So as you see, the symbols are green, so it didn't shut down. So it accepted two systems on this interface, and you will be able to see the MAC address updated over there. Now we'll have a look at spanning tree protocol. So what is STP? STP stands for Spanning Tree Protocol. The need for the Spanning Tree Protocol (STP) arose because switches in the local area network (LANs) are often interconnected using redundant links to improve the resilience if one of the connection fails. Above connection configuration creates a switching loop, result in broadcast radiation and MAC table instability. Let's have a look at few basic terms. First is root bridge. The root bridge of a spanning tree is a bridge with smallest, lowest bridge ID. Each bridge has a configurable priority number and a MAC address. The bridge ID is concatenation of the bridge priority and MAC address. For example, the ID of a bridge with priority 32768 and MAC address as given, the concatenation will be as follows, as you can see on the slide. What is BPDU? To ensure that each bridge has enough information, the bridges use special data frames called bridge protocol data units to exchange information about bridge IDs and route path cost. So what is path cost? The STP path cost default was originally calculated by the formula 1 gigabyte divided by the bandwidth. When faster speeds became available, the default values were adjusted as otherwise speeds above 1 gigabytes per second would have been indistinguishable by STP. Its successor RSTP uses a similar formula with larger numerator, 20 terabyte per second divided by bandwidth. These formulas lead to sample values in the below mentioned table. Now let's have a look at the port states. All switch ports in the LAN where STP is enabled are categorized as follows. First is blocking, a port that would cause a switching loop if it were active. To prevent the use of loop paths, no user data is sent or received over a blocking port. BPDO data is still received in the blocking state. A block port may go into forwarding mode if the other link in the use and spanning tree algorithm determines the port may transition to a forwarding state. Second one is listening. The switch processes BPDUs and awaits possible new information that would cause it to return to a blocking state. It does not populate the MAC table and it does not forward frames. Third one is listening. While port does not yet forward frames, it does learn source addresses from the frames received and adds them to the MAC table. The fourth one is forwarding. A port in normal operation receiving and forwarding the frames. The port monitors incoming BPDUs and would indicate it should return to a blocking state to prevent a loop. Then there is disabled. A network administrator has manually disabled the switch port, so that's the disabled one. Let's talk about what is rapid spanning tree operation. The rapid spanning tree operation has bridge port roles involved. So the first one is route, a forwarding port that is best port from non-route bridge to a route bridge. Then there is designated port, a forwarding port for every LAN segment. Then there is an alternate path to the route bridge. This path is different from using the route port. Then there is backup port, a backup redundant path to a segment where the another bridge port already connects. Then there is disable, not strictly part of STP. A network administrator can manually disable a port. Then there are port states reduced to 3 instead of STP's original 5. First is discarding, no user data is sent over the port. Then there is learning. The port is not forwarding frames yet, but is populating its MAC address table. Then there is forwarding. The port is fully operational. So let's move on to spanning tree protocol demonstration.
To begin with STP demonstration, we have three switches and three PCs, and I've already configured them for interconnectivity. And as you can see, like there is a orange dot, which means it is either blocked or alternate route given by STP, which is already running in the background. So let's go to switch to enable, and then let's do show spanning tree to check the spanning tree configurations. And you will see that there is priority number and the MAC address given over there. So you will find the root ID. You will find the ID of the root bridge present in every switch. See, so let's keep it side by side for comparison. Now here you can see the priority of all the three switches are same and the MAC addresses are different. So according to the STP protocol, the root bridge will be decided on the lowest MAC address. So as you can see, the lowest MAC address starts with 0002, which is the switch to. So by default, that has been selected as root bridge. You can even check the cost over here, which is 19. At the bottom of spanning tree config, you can see the role of every port, whether it is root, designated, alternative, blocked, everything. Also the status. So let's go to switch 0, and what we'll do is we'll try to configure switch 0 as root. So the syntax is spanning tree, and we have to give what VLAN it belongs to. We can do it based on priority or simply write it as root. Then after in question mark, you will see that primary and secondary is there, so we will give it as primary. So you will see that the switch is working in the STP protocol is working in the background, and you can see the two orange dots over there, and one of them has turned green now. So successfully we have managed to change the switch 0 to root bridge. We'll check the spanning tree configuration. Now switch 2 is no longer the root bridge. Simultaneously you can see that the switch 0 is now the root bridge. Also note the priority of switch 0 from. Now we'll simply try to ping the server from PC1. Okay, so it's following the route as expected. Now what we will try to do is we will try to shut down one of the interface, and let's see how the STP will work. Before that, we will continuously keep pinging from PC1 to PC0. Okay, now that we have over there, we will just shut down interface F04. Go to configuration terminal, and interface 04, shut. So as you can see the symbols have changed to red and the connection has been disconnected. But give some time and STP will figure this out and will provide an alternate route. There you go. So orange symbol has turned to green and the alternate route has been found. That's it with the STP demonstration.